Okay, so section 5.2. So we're going to start with looking at our Riemann sums again. Okay, so it wants to use the midpoint, and we've got 4 subintervals in this case. Okay, so let's see. All right, so I know that since my values are 3 and 1, I can subtract them and divide by how many subintervals I have, which gives me 1/2. So my change in x, my length, is 1/2. Okay, so from there, I can go ahead and set up my interval. So we're going to start with 1 and then 1.5. Then 1.5 to 2. Then 2 to 2.5. And 2.5 to 3. Okay, so now we're going to go ahead and find the midpoint. So to do that, remember we add and we divide by 2. So I'm getting a midpoint of 1.25, 1.75, 2.25, and 2.75. Okay, now what I'm going to do is, because this is, it's got 2 pieces to it, it's 1 minus x squared, I'm going to go ahead and plug in that value. So I plug in my midpoint value. So if I plug in 1 minus 1.25 squared, I'm going to get negative 0.5625 and negative 2.0625 and negative 4.0625 and negative 6.5625. Okay, so I'm going to go ahead and add all of those together. So I'm going to get negative 13.25. And then essentially I'm going to multiply that by my length of 1/2. So I'm going to end up with an answer for my area as negative 6.625. Now you might be thinking like, what? That's negative? Okay, so let's see what happens when I look at this graph. Okay, so our midpoint for our Riemann sum using the equation f of x 1 minus x squared gives us the negative 6.625. Okay, so why is the value negative? The value is negative because we have negative numbers. Area is a non-negative thing. Therefore, this Riemann sum does not approximate. I need to go to the next line. Approx the area. Okay, so this Riemann sum is not a good approximate because it's negative, and we know area is not supposed to be negative. Okay, so we're going to do the same problem, and we're going to now use the left interval. Okay, so I'm going to see if I can just copy and paste this to the next slide. Let's see. Did it work? Yeah. Okay. See if I can move it up though. No, I guess not. Here we go. Yeah, look at that. Awesome. Okay, that's exciting. It's the little things that, make it really exciting. Okay, so we're using the left value. Okay, so that means I'm plugging in 1. So I'm going to go ahead and plug that in. So we're going to do 1 minus, oh, you know what? I got so excited because I thought I could do this, but look, we want 6 subintervals this time. So I actually don't need this. Okay, boo. All right, so let's see. Since we have, oh, and if the numbers are different too, we're going from 0 to 3. All right, so 3 minus 0 is 3 divided by 6 is 1/2 again for my length. Okay, so let's write these down. We have 0 to 0.5, 0.5 to 1, 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3. Okay, so left. We're dealing with this. Okay, so I'm going to go ahead and, just like last time, I'm going to plug in the values. Okay, so we're going to plug in 0 and we're going to get 1.75, 0, negative 1.25, negative 3, negative 5.25. So essentially what I just did was I did 1 minus each of the left terms plugged into this equation. All right, so I'm going to go ahead and add them together. And that is going to give me negative 7.75. And we always multiply by our length. So our length is 1/2. So we're going to get negative 3.875. Okay, so let's look at this graph. So in this case, what our Riemann sum is doing is it is approximating the area of the regions that lie above the x-axis minus the regions that lie below the x-axis. This difference between the positive and negative regions is our net area. Okay, so let me type that out. Okay, so net area. Okay, so what this is saying is our net area is the sum of the areas above the x-axis minus the sum of the areas below the x-axis. Okay, so what this looks like, let's just draw a little picture. Okay, so I could have something like this. Okay, that's perfect. You gotta make the sound effects when you draw it too. Okay, so this, and this is my area above, my regions above. All right, and then below we've got this. Okay. So one other thing that we're going to draw your attention to, a few more rules before we get into some practice with this. All right, what this is saying to us is so far all of the rectangles that we've been creating with our Riemann sums have been equal, but that's not always going to be the case, okay? Sometimes the rectangles are not going to have equal length, all right? So how this applies to what we've been doing is we can take our integral and we can express it as a limit, okay? And we can do this to figure out to help us figure out what the area is. So what we have is we have a and b, which are our lower and upper limits of integration respectively, and that is going to mirror the lower and upper limit of your summation, okay? In this case, x is our variable of integration, and notice here we have that change of x still coming into play, okay? So although maybe this looks a little bit scary, we're gonna run through this together, okay? So what this is saying essentially is we are going to take the antiderivative, okay? Okay, so let's just start out nice and easy. So we have this, it right now is expressed as the limit, and it wants us to represent this geometrically, so not as a limit anymore. So what we're going to do is we're going to write our integral symbol. Our lower bound is 1, and I'm getting that from here. Our upper bound is 3. Okay, and then what I'm going to do is I'm going to replace each of these with an x. So I'm going to end up with 3x squared plus 2x plus 1 dx. Okay, so what does this look like if I were going to try to find the area? So we're going to have our x and our y axis, right? And I'm going to have 1, 2, 3. This is a quadratic, so I know it's going to look like a parabola. So it's going to be something like that, right? And then essentially what I'm going to do is I'm going to figure out the area, okay? All right, so we're not actually going to do this one. We're going to start more basic. Okay. So in this case, we have, first we're going to make a graph. So we are going from 2 to 4. So 1, 2, 3, 4. And how high do I need this graph? Let's see. So in order to figure out, first, what I want you to do is you're going to substitute in the value for 2 into x. So you're going to do 2 times 2 plus 3, which is going to give me 7. And then you're going to do 2 times 4 plus 3, which is going to give me 11. Hey, 7, 11. Huh. Okay, so I need all the way up to 11 here on the y-axis. Okay, so what we're going to do now is we are going to plot the point 2, 7. So 2, 1, 2, 3, 4, 5, 6, 7. And then we're going to plot the point 4, 11. Okay, so now what we're going to do is we're going to connect those. And the next thing that we're going to do is we are going to drop these down straight here. Whoop, that's not that straight. Whoops. All right, you're going to have to work. You're going to have to work with your imagination here and my incredible drawing. Okay, so I'm trying to find this area. Now, I need you to think back to your geometry days. And some of you are groaning. I can hear you. Stop. This shape right here is a trapezoid. And so what I can actually do is I can figure out the area of this. Okay, so the formula for the area of a trapezoid, remember, is 1/2 height times b1 plus b2. Okay, so think about this. The height of your trapezoid, when you are dealing with these problems, is the distance between the parallel bases, okay? So in our case, our height is going to be 2. Now, to get the bases, that's the parallel sides. That's going to be this and this. So this distance from here to here is 7. And this distance from here to here is 11. Okay, so now I can substitute this in to find the area. So I'm going to say 1/2 times 2 plus 7 plus 11. Okay, which is 18. All right, awesome. Let's do another one. So this one's going to look a little bit different. We're not going to do a trapezoid this time. Okay, so just like before, let's go ahead and substitute in 1 and 6. All right, so then we're going to get -4. And 6. Okay, so let's go ahead and plot that. Okay. So this one would have been better to do on like a real graph paper and not just Mac freehanding it. Okay, so we get 1, -4, so that points down here. And I'm getting, what, 6? 6? 6. Okay, so we're going to connect these. Okay, so now I did kind of a bad job of making my graph. And I need to know where this is actually crossing the x-axis. Okay, so what you could think about with that is you could find the you could find the x-intercept, and you would do that by setting y equal to 0. So if I were to say 2x minus 6 equals 0, I would add 6 over, so I'd get 2x equals 6, divide by 2, which would give me x is 3. Okay, so I know that my blue line, even though I didn't do a very good job of drawing that, should be here at 3, 0. That's going to help me when I am finding the area. Okay, so how am I going to find the area? And to do that, what I'm noticing is if I connect this here like this is a triangle, right? And this is also a triangle. Okay, all right, so let's go ahead and knock this out. So we know that the area of a triangle is 1/2 of your base times your height, okay? So in this case, I know that this is at 3, so this gives me 1, 2, 3 here. And this is going all the way up to 6, okay? So to find this area of this top triangle, it's gonna be 1/2 times 3, 1/2 times 3 times 6. So 18 is 1/2, which is going to give me 9. All right, now I got to do this side. So we know that this distance right here is 1, 2. This distance on the side is 4. So I'm going to say 1/2 times 4 times 2, which is going to give me 4. Okay. All right, so now you know that we're going to find the net area. And to do that, it's going to be sum of the top area minus the bottom area. Okay, so in this case, it's going to be 9 minus 4, which is going to give me a net area of 5. Okay, you could also think of it as addition. So you could say 9 plus negative 4 if you want to think about it that way. Okay. So for the next thing, what I want you to do is I want you to actually plug into Desmos or your calculator. This equation right here, just this piece with the square root and everything. All right, what does it look like? A half a circle, right? Or semicircle. Okay, so let's go ahead and plug in our value of 3 and 4. And when I plug in 3, I got 1. And when I plugged in 4, I got 0. Okay, so let's go ahead and graph this. 1, 2, 3, 4. Just give myself a little bit more room. I only really need 1. Okay, so our circle, I hope you still have it pulled up. We had 1, 2, 3, 1. We had 4, 0, right? And so our circle looked like this in Desmos. And sorry, that's a little crooked, okay? Right? So it was a semicircle. And what is the radius? In this case, the radius is 1, right? All right, so now the other thing that I want you to think about is our interval is from 3 to 4. So essentially, I only care about this little piece right here, okay? So what is the formula for the area of a circle? The formula is pi r squared, right? But in this case, I only care about this piece of the circle, and that's a quarter of the circle. So I'm going to say 1/4 times pi times 1 squared. So that's going to give me an area of 1/4 pi. Okay. All right. So that's been fun, right? But let's switch it up a little bit and let's do some more problems. A little bit different. Okay. So this one is going from A to B. Okay, so the area from A to B is 12. All right. Next, we are going from B to C. All right, so that area is going to be -10. -10, why? Because it's below the x-axis. Okay, now A to C. So we have a +12, a -10. Gonna get 2. All right. One more like this. Going from B to D. So we have a -10 and a +8, which is going to give me -2. Okay. Okay. So now what we're going to do is we're going to talk about the different properties of our integrals. Okay, so a lot of these mirror the rules that we've been working with our summation and even our limits. And if you remember back to pre-calc, like logs, different things like that. So what it's essentially saying is when this one is really nice. If you have the same number, it's going to be 0. Notice here I have A, B, and then it's B, A. What happens? You're going to do the opposite of whatever it is. Here, if you've got addition or subtraction, you can split them up. Here, if you have a constant, you can take that out. And then this one's really cool. So what this one can do is you can break this up into a smaller subset. So in this case, it's the value from A to C, and then this one takes over and goes from C to B. So pretty cool. And then the last thing is whenever you are doing the absolute value, you need to know the regions where it is negative in order to be able to do that problem. So if you don't have the regions, you're not going to be able to do it. Okay, so let's go ahead and knock this out. So in this case, we have these two sets up here is given, and we're going to try to evaluate this. All right, so the first thing that I'm noticing is number 1, I'm going to take my 2 out. So I'm going to say 2 is on the outside, 0 to 7, f of x dx. Okay, so then the next thing you look for is which one of these is going to be more helpful, and it's this one right here. So I have 0 to 7, and the answer is -10. So what I can do is replace all of this with -10. So we're going to say 2 times -10, which is going to give me -20. Okay? All right, let's do another one. Okay, so this is an interesting one because this is going from 5 to 7. Neither one of these go from 5 to 7, but what I can do is I can split up this one here into 2 pieces. So that's what I'm going to do. I'm going to say, I'm going to rewrite 0 and 7 f of x dx is equivalent to 0 to 5 f of x dx and 5 to 7 f of x dx. Okay, so I can solve this first and then plug in, or I could plug in and then solve. So I'm going to plug in and then solve just because that's what I want to do. So this is -10, and this is 3, and I'm trying to find this. So we're going to subtract 3. We're going to end up with -13 equals, oh, I wrote that wrong. Mm-hmm. All right, that one's done. All right, so this one's cool. So this I have 5 to 0, and this was 0 to 5. So when they switch like that, you're just going to do the opposite. So we're going to get -3. Okay. Next. All right, so this is got a lot going on here. We can take out the 6. Okay, and then the other thing that I was noticing is this and this are reversed. Okay, so I would do the opposite of -10. What's the opposite of -10? +10. So we'll do 6 times 10, which is 60. Okay. Now this next one is a trick question. And why is this one a trick question? It's a trick question because they did not give me the intervals from where this is positive and negative. So we cannot do this. Okay. All right, so let's do some more. Okay, so in this case, they did give me my intervals, and this is telling me when it's greater than 0, so positive, and less than 0 is negative. All right, so that means when I do the absolute value, I'll actually be able to do this one. Okay, so this is going from 0 to 5. Okay, so essentially, when we're going from 0 to 5, that would be like me going from 0 to 2 and then from 2 to 5. Okay, so I could actually write this as 0 to 2 f of x dx and 2 to 5 f of x dx. So what I would do is I would say 6 plus negative 8, which is negative 2. Okay. All right, the next one is very similar to what we just did, except this time it's taking the absolute value. So that means for us, we are going to do the absolute value of 0 to 2 and the absolute value of 2 to 5. So the absolute value of 6 is 6. The absolute value of negative 8 is 8. And we add it together to give us 14. Okay. You want to take care of doing the absolute value before you add them together. Okay. All right. I want you to try the next two. So pause and try. Okay, so hopefully you did this one. If you did correctly, you would have gotten 32. See me if you did not get 32. And this one, you should have gotten 12. So if you did not get that, let me know. All right, this one we'll do together. So in this case, they are giving me cosine minus 2 sine. So this looks really similar, except my signs are switched, right? So what I could do is I could take out a negative from here, and then I would be left with a positive now cosine theta and a negative 2 sine theta. So that would be the same thing as what I had up there in my given. So this I know is negative 1. So it's a negative 1 times negative 1, which would be positive 1. All right, let's do one more like this. Okay, so let's see. What do we have? What are we noticing? Okay, so first I know that I've got a 4 here and I've got a negative 8 here. And I know I need to get this to be 2 in front of my sign. So that means I'm going to have to factor out a 4. So then I'll be left with cosine theta minus 2 sine theta d theta. Okay, so then the next thing I'm noticing is my interval numbers are switched. Okay, so what does that tell me? that this, hold on, I want to switch colors. That this is equal to the opposite of this. So the opposite of -1 is 1. So we're going to say 4 times 1. And bam, done. Okay. Last 2 examples. We got this. Okay, so with this part, what we are going to do is we are going to turn these Riemann sums into their summation equivalent so that then we can do the limit. Okay, so this is going to be a little bit of a long example. All right, so the first thing that we need to find, so step number 1, is we need to find our change in x. So our rule for our change in x is you're going to take your b minus your a divided by n. So in this case, b is 2 minus 0a, all divided by n is going to give me 2n. Okay, so we want to do this because we don't know what n is. N is going to go to infinity. All right. Okay, step number 2. So for step number 2, we need to find h bar k. So the rule for that is a plus k times the change in x. So a is 0, k is k, change in x is 2 over n. So we're going to end up with x bar k is equal to 2k divided by n. All right. Next. So the generic formula, I'm going to switch colors now, for how we are going to write this is summation k equals 1, n we're going to infinity, f of x bar k times your change in x. So what we're going to do now is we are going to plug in x bar k to the original function of x cubed plus 1. So let me just type that real quick. All right, so we're going to say 2k over n cubed plus 1. Okay, so that was plugged into my original function. And then we need our change in x, which is our 2n. Okay. So first, what I'm going to do is I'm going to write, so n is a number, right? So that means 2 over n is a constant. What can I do with constants in my summation? I can bring it to the front. Okay, so then we're going to say 2 over n Okay, now let's go ahead and you could think of it as distributing the cube in. So we get 2 cubed, which is 8, k cubed over n cubed plus 1. Eight. I also, okay, of course. All right, so we're going to bring this out. All right, so we're going to bring this out. So I'm still going to have on the outside my 2 over n. And then I'm going to have 8 over n cubed. And I'm going to have my k cubed. So summation k cubed plus summation 1. And still starting with k equals 1, going to n. Okay, so then what you're going to need to think about is the rules that we discussed in 5.1 give you a value for k cubed and give you a value for 1, okay? So reference that because that's where I'm getting this next part from. So we're going to still have, let me see if this will work again. Yeah, it's not working. Okay. So 2 over n, 8 n cubed. Okay, so k cubed, the rule from 5.1 is that it equals n squared times n plus 1 squared. All divided by 4. And then the summation rule, when I have a 1, that's going to turn into an n. So we'll say plus n. Okay. Oh, my big brackets here. Whoop. All right. So now we're going to clean this up a little bit. So I know that 8 divided by 4 is 2. I have an n cubed, and I have an n squared. So I could get rid of that guy, and this would just be an n. Okay. So then in essence, what I'm going to end up having here is 2n. So 2 times 2 is 4 times n plus 1 squared, all divided by n times n, which would be n squared. Okay. All right, and then we're also going to distribute this 2n to this guy. So 2 over n times n is just going to end up giving me 2. Okay. So now what we're going to think about is we're going to think about the limit. So we are evaluating this as the value of n goes to infinity. Okay, that's an 8, not an infinity. All right, so as n goes to infinity, essentially what is going to happen is this is going to go to 1 because we're going to have infinity divided by infinity. This is going to go to 4. So 4 times 1. And 2 is going to go to 2. So our answer is 6. Bam. Okay. All right. You are going to try the next one. The answer for the next one is 2/3. So actually try it, okay? And if you don't know how to do it, you need to get with me so that we can work together. But essentially, you're going to do the exact same process that we did. You will need your summation rules from 5.1.